Hi guys, today we're going to do last stone weight. So we're given an array of integers called stones where stones at I is the weight of the ith stone. We're playing a game with the stones. On each turn, we choose the heaviest two stones and smash them together. Suppose the heaviest two stones have weights x and y with x less than or equal to y. Then the result of this smash is if x is equal to y, then both stones are destroyed, and if x is not equal to y, the stone of weight x is destroyed, and the stone of weight y has a new weight of y minus x. So basically, we always select the two heaviest stones, and if the weights are equal, then they're both destroyed. If they're not equal, then the lighter one is destroyed, and the heavier one becomes a weight of the difference of the two weights. So at the end of the game, there's at most one stone left. Return the weight of the last remaining stone. If there are no stones left, return 0. So if we take a look at example 1, we're given this input array, which I have copied and pasted here as well, and we would return 1 because so at every moment, we're selecting the two heaviest stones and smashing them. So our two heaviest stones first is 7 and 8, and I've put the array here in sorted order as well so that we can sort of see what's going on as we go, sorted by heaviest to lightest. So we first start with 7 and 8, which are our two heaviest stones, and since they are not equal to each other, then we would destroy the lighter one, which is 7. So 7 gets destroyed, and then 8 becomes the difference of the two. So 8 minus 7 is 1, so 8 becomes 1. And then if we want to remain in sorted order, then we can add the 1 to the end like that. So then the next iteration, our two next heaviest ones are 2 and 4. So since these are not equal again, so we would remove the lighter one, which is 2, and then the heavier one, which is 4, becomes the difference of the two, which is 4 minus 2, which gives us 2. So we would remove them both and then insert the difference back, and then this is our new sorted array. So then the next iteration, we have 2 and 1, which are our heaviest remaining stones. These do not have the same weight, so again, we remove the lighter one. Well, yeah, we would remove them, and then the difference of these two would be 2 minus 1, which is 1. So we can add that back in, and that's our new sorted array. Then the next iteration, we have 1 and 1, and since these are the same, we just destroy both of them and don't add anything back. So then this is our sorted array after removing both of those. And then now, since we only have one stone left, there is nothing to smash this against, and so we would just return the weight of the last remaining stone, which is 1. So that's how we get 1 here. In example 2, we only have one element, or one stone, so we just return the weight of that one stone, which is 1 in this case. So we're going to implement this using a max heap, because that way we can repeatedly access the heaviest two stones as we go. So let's start out by doing that. So I'm going to delete that, and then we're going to do a priority queue of integers, and I'll call it heap, is new priority queue. And then we're going to do comparator dot reverse order. And so the reason I'm doing that is because in Java, it automatically initializes all heaps as a min heap. So by reversing the order, then we can make it a max heap, which is what we want in this problem. So then we're just going to iterate through all of the stones in stone and add them all into our heap so that we can maintain the sorted order. So for each stone in stones, we'll just add it to the heap. Okay, then once we've added all of that, we are just going to want to loop through the heap and continually access the two heaviest stones in each iteration and compare their weights to each other. So if they are equal, we will remove both of them. If they are not equal, we will remove them both still and then add back the difference of the two weights. So while our heap's size is greater than 1, because we could have at most one stone remaining at the end, right, which is what we had in example 1 and example 2. So while that is the case, So we're going to keep removing 2 stones at a time. So we'll say first is heap.remove. Second is heap.remove, because once we've removed the first one, then the second one will be the second heaviest one. And then if they're not equal in weight, so if first is not equal to second, then we will add back the difference. So add, let's see, so the first one would be 8, in this case, the second one would be 7. So we're going to add back first minus second, which would be 1. And then we're going to do this for every iteration until we have nothing left. So if we think about it, again, this is not even how heaps are actually implemented, but just so it's like easier to wrap our brain around it, I'm just going to display it like this. And let me fix this again. Okay, so this would be our sorted order, right? So first would be 8, second would be 7, and then we remove both of these in our loop, our first iteration of the loop. And also heap.size starts out as 2, 3, 4, 5, wait. Yeah, 6 is our initial size, which is greater than 1. So we enter the loop, remove both of these elements, and then we add back in a 1. So like that. Then the next iteration, right, our size is now 5. And then we would remove the first and second element, which is 4 and 2. And these are not equal, so we would add back in the difference of the 2, which is 2. So then this is our new heap. Then the size becomes 4. And we added 2, sorry. Then first becomes 2, second becomes 1. These are not the same, so we would add back in the difference, which is 1. So then that's our new heap. Then our size is 3. We would remove, or sorry, first is 1, which we remove, second is 1, which we remove, and then these are the same, so we don't even enter this loop. We just removed these from here. Now our size is 1, so we don't even enter this loop because our size is equal to 1, which is not meeting this criteria. So we don't enter this loop, now we're done. And then that means once we are done, then we want to return, so if our size of heap is 1, we have 1 element left, then we will return the weight. But if we have no stones left, then we would return 0. So if heap is empty, then we have no stones left and we would return 0. Otherwise, we will just return the top element's weight, which would be, if we removed it, then it would be that element. So that is it. Let's see. All right, so, oops. Time complexity. So let's think about what we're doing here, right? We first looped through the stones array and added each stone into our heap, which is what we do here. And in this loop, we are, so when we loop through the stones, that is O of n, because we are processing every single stone exactly 1 time. And when we add each stone into the heap, which is here, so add insertion into a heap is going to be log n, but since we're doing this for n stones, that would be O of n log n. So like that. Since we're doing the insertion n times for n stones, right? Does that make sense? Then if we move on to the while loop, so now we are looping through the heap, and the heap also stores every single stone, so we have n stones in the heap. So this loop is going to iterate n times, basically, because we need to process every single stone, right? And then also because every single iteration, we are removing 2 stones and then potentially adding 1 stone back. So this is like n times, if we think about it. And then each removal, so each of these, costs log n, because removal in a heap is log n. And then we also have a potential insertion, which is another log n, because insertion in a heap is also log n. So then if we add all of these up, that would be log n plus log n plus log n, which is 3 log n, which just simplifies to log n. And then because we're doing these two removals and one insertion for every iteration, and we are iterating this while loop n times, then this would become O of n log n, if that makes sense. Then in our final statement here, so this is constant because it's just a simple if statement checking if it's empty. This is going to be log n if we do the removal. So worst case, this part is log n, but it could also just be constant. But regardless, it doesn't matter because it gets overridden by these two, which are larger. So if we add these up, then that is 2 O of n log n, which is just O of n log n. So if we simplify all of this, we get O of n log n, where n is the number of stones that we have. Okay, now let's do space. So our space, so if we think about all of our data structures we have here, we have this priority queue or heap, which stores n stones, because we are adding every single stone that we get in this input array into our heap. And that is the only data structure. So then that's pretty simple. So we just end up with O of n for space, where n is the number of stones. So that is it for this problem. I hope you guys found it helpful. If you did, please like and subscribe, and I'll see you guys next time. Bye!